Hey, good evening, everybody. Thanks for joining us tonight for the second Coding Connect podcast, conversation, whatever you call it, where we take a little bit of time to talk to somebody who's been involved in programming, whether they're an educator or a programmer or an educator programmer, an edugrammer or a proeducator, whatever it may be. We like to bring them to you and get the full story on this thing called coding as we try and wrap our heads around it, approaching this year's hour of code and how we can integrate coding from beyond. So I'm really excited this week because we have an awesome special guest. But before I introduce him, I'd like to introduce my partner in crime and the mastermind behind the whole Coding Connect thing, Tara Linney. Tara, how's it going?
Hi, it's great. I'm still getting used to the snow out here in the Chicagoland area, which we don't really have that much compared to Buffalo. So it's going pretty well.
It'll be coming, don't you worry. You haven't lived here long enough yet to know whether or
No.
not. Yeah, it's coming. Well, awesome. Glad you're doing well. Thanks for being a part of this tonight. And now, for a super duper special guest, we have Manan Shah, and I believe I pronounced that correctly, right?
It's to within, reasonable, accurate pronunciation.
Awesome. How's it going, Manan?
It's going well. How about you? We actually haven't had too much snow at all here in New Jersey.
Yeah, snow in mid-November, kind of a weird conversation, but tis the world that we live in, I guess, in 2014.
Yeah, it's a lot better than what we had just a little bit ago with Sandy. So
Yeah, it's not, yeah.
glad I don't have that again.
Yeah, and that was only, what, 2 years ago at this point? Three?
Yep. Yep. Yeah.
Okay. Yeah, very cool. Well, I'm glad that this is minor compared to that. I mean, it is annoying, but it's livable as long as you're not in Buffalo.
Right. Right.
So I mean, in all seriousness, that's pretty awful. So I hope that stops soon, and they can start to unearth themselves like some kind of archaeological dig. Um, yeah, it's crazy. I've seen those pictures. Glad I don't live there. So anyways, segueing towards our topic, we could talk about the weather all the time. Like, wow, we just jumped right to the weather. We actually have a lot of great things to talk about with Manan. Manan, why don't you just tell us a little bit about what it is that you do right now and kind of your career progression, and maybe
Oh,
how it
okay.
relates back to programming then.
Yeah. Well, so in terms of a career progression itself, I started off, after college, I got a bachelor's degree in electrical engineering, and I actually didn't want to do any electrical engineering, and so then I had to figure out how to get a job, and I remember this day at talking to my father, and he said, well, you've been hanging around here a little too long. When are you going to get a job? And so I said, well, I should start looking, and I did, and it was very interesting because one of my first jobs was in commercial real estate finance, and they had advertised that they were looking for people with an engineering background to do finance. So when I asked them, I said, well, why? They said, well, we can teach you the math. We can teach you the finance. We just can't teach you the math. And if you have an engineering background, you already know the math. So that's how I got started in real estate finance. And then to make a very long story short, I left that job because I realized that I actually didn't know enough. In fact, I didn't know anything. Uh, because we faced a lot of problems, pricing certain types of deals, and the people that they would have to bring in as consultants had doctorates in mathematics, and they were researchers, and they knew how to program, and they knew advanced methods and techniques, and they just knew a lot more. So I said, well, looks like I have to go back and learn a lot more because I clearly don't know enough. So I started graduate school, and throughout the whole graduate school process, I realized that, okay, well, if I'm going to learn mathematics, I also need to be able to apply it, and I need to be able to apply it in a modern sense. And that modern sense really meant I need to be able to program. Um, so so I really started to learn program in graduate school, I had known a few things about programming earlier, but never really, okay, let's write, some software, that kind of thing. And that eventually brings me, I can skip a lot of the details in between graduate school and today, but eventually, gets me to today where I right now, work as a consultant, and I teach part-time. I continue to teach part-time because I've always enjoyed teaching. I enjoyed teaching when I was high school, when I was in college, when I was in graduate school, and even at the places I worked, I like to run trainings. I train folks in how to use their spreadsheet, how to program their spreadsheets, how to just make their lives a little bit more optimized. And that optimization really came through a little bit of automation, and automation comes from programming. So now what I do is a mix of a lot of things. One, I do some technical education stuff for a lot of folks who have been working, but they have been finding themselves to be running out of their job because it's being replaced by a program. And they want to now know how to program so that they can at least maintain the thing that's actually pushing them out of their job. So I get a lot of individuals who say, well, can you teach me how to program? They don't want to go to college to go back and to take a course. They just need to learn what they need to learn, and then they can learn everything else on their job. And then the other thing I do really is more at the corporate consulting level, where I'll work with small businesses. They have some type of data that they need analyzed. They have a special product that they need analyzed. And to do that, it requires mathematics, but it also requires the ability to implement that mathematics. And that implementation is by programming. So that's currently what I do.
Right. Well, very cool, and I love how you kept hitting on math, and programming, almost like they're synonymous. Do you definitely see that the two go hand in hand a little bit?
I think in certain contexts they absolutely do. They absolutely do, because math is the world of numbers to some extent, and math is also the world of ideas and just a general abstract framework for how to approach problems and how to solve problems. But with that said, there's the nitty-gritty, the ground level math. I mean, what's enabling us to talk in this fashion right now? Across, where are you, Wisconsin, and I'm in New Jersey, and somebody else is in Chicago. What's underlying all of that is mathematics, right? And it's sort of this invisible thing that just is doing what it's doing. So the world that we have here, I think the modern conveniences that we have, the underlying framework is a mathematical one. We just don't see it as often.
Right, and I think that's great, and I think it's a great selling point for math and programming, and how programming can really help teach the math. Would you agree with that?
Yeah, I think in general it's I have tried to bring math and I've tried to bring programming into my math classes, and I've tried to bring mathematics into my programming courses. And I think that there is a way, obviously, to mix the two worlds together. What an algorithm is in some sense just a sequence of commands that have to get executed. But in mathematics, we work with functions, right? We work with functions all the time, and I'd like to be able to program them, and I'd like to be able to analyze them. And there is a very, very distinct overlap between what we can do mathematically and then how we can program it, and back and forth.
I always kind of love that in programming terms, you executed things in a terminal. I always thought that was kind of funny. But anyways,
I see. Yeah.
I digress with my horrible sense of humor. All right, so very cool. So you touched on this a little bit. You said that you really started to code in graduate school. Would that be where you first learned, or was there something before that where you had an experience?
Oh yeah, sure. When I first really my first real exposure to computer programming, I think I was in the fourth grade or the third grade. Um, I'm probably dating myself now, but I programmed in Logo. It's that turtle program where you had
Yeah.
to make the turtle go around the screen. Uh, and I remember distinct. I have very fond, I shouldn't say fond, but I have memories of doing this. And that was really my first exposure to programming, where you had to make this turtle do whatever it was supposed to do. And then after that, I got my dad put me into some summer programming course. I think when I was in the fifth or sixth grade, and I had no idea what I was doing. We were programming in Pascal. I didn't understand anything. I knew that there was in fact, I don't remember what Pascal looks like anymore, but I think there was a begin and an end, and then I didn't really have any idea of what was going on. But what was interesting was for that summer, I just got to stare at a computer screen with all these code kind of things around. So so that meant at the very least that I had exposure to it, even if I didn't get anything out of that. Because then in high school, my high school offered a programming course, and so I took it. And again, I had no idea what I was doing. It was a foreign world. It made no sense whatsoever. But over time, just those little bits of exposure meant that when I think maybe my brain was developed to handle this, or I was receptive to the idea of programming. That's when all those little memories, maybe that they didn't make any sense then, somehow, some way, they just marinated in my brain, and then I was just programming wasn't this mystical thing, and it was just because of all those exposures. Even if I wasn't able to produce any program as a kid, I just still mashed on the keyboard and did a few things. But then as I got older, the first time I was really taking a look at, say, code, I knew that this was code and it was supposed to be something that was a little foreign, as opposed to seeing it for the first time and then being, overwhelmed by the foreignness, if that makes any sense.
That does. Tara, that's, I don't know if you were thinking the same thing I was when he was saying that, but isn't that like a great marketing slogan for getting kids coding as soon as possible?
Yes, I mean, because it's like acquiring a new language. So it's like you hear maybe Spanish or something when you're younger, and then it's not until you're an adult where you're like, wow, I'm speaking in full sentences now, and it actually makes sense because I'm able to apply it to something.
Yeah. So I
Cool.
I definitely liked what you had to say there, because I can apply this to my own experience in that I learned Google scripting from two awesome guys, David Tess and James Eichmiller, who probably aren't happy that I am constantly like fawning over them, but they created this Google script curriculum and ran this workshop for teachers last February, and it was like 18 hours or 17 hours over a weekend, a Friday and a Saturday. So just like straight coding, like coding the whole time.
Right.
And by the end, like I was burnt, like I was done, my brain fried, like I literally couldn't process anymore. And I ended at the point when we started to talk about loops, and I just didn't get it. Like it just made no sense to me. Everything we were doing up to then was easy. Like it was just kind of simple math, simple syntax. Then we got into these loops, and it was like, yep, I'm done. I can't. It doesn't make any sense. Well, fast forward to September, and my school had this really simple need that we were trying to simplify this, almost this check-in, check-out type system, and I'm seeing that we can write a Google script for this. And so originally I write one because I kind of knew how to write one to auto email, but that didn't really get us to the checkout point. So then I got some help from David Tess once again, and he used loops. And somehow, like looking through the code that he wrote, it clicked for me. And I've actually been able to apply that and write my own loops that actually work and do what I want them to do now. So it took months of just kind of letting it alone and then coming back to it, and then in that application came in, and then it clicked. So I love that point because I can parallel that in my own mind, in my own life, but I can also see how that could be beneficial for students because if they don't get those little breadcrumbs along the way, then they're going to have a harder time making that decision when they get out of high school or even in high school if they want to do more programming.
Absolutely, absolutely. Yeah, because that was exactly what it was for me, where I said, oh, okay, I at least had seen what a computer program looked like, and I had seen, and I understood the fogginess. I was okay with the fogginess. I'd at least gotten exposed to the fact that, hey, this is just a little foggy, as opposed to seeing it for the first time as an adult and saying, okay, I don't know what this is, and then giving up.
Yeah, yeah. So I think there's a lot to be said for that. So I'm really glad you brought that up completely unprovoked. That was excellent, excellent. All right. So getting into a little bit more of programming-specific stuff, just because I think you might have more experience than a lot of educators that we've talked to thus far. What would you say your favorite programming language is?
Oh, okay. So I have to say, I have to just say that it has to be Python, just because I end up defaulting to it whenever I want to program. But I've started to come to recognize that, hey, there was a time in my life that I liked C++ the best, and it was just because that's what I had programmed in, and I got very comfortable and very familiar with it. Now I've started to do a lot more JavaScript for some of the web-based stuff, so I've started to enjoy JavaScript because it has a few more things. Well, it has a few other things that are just, I like the loosey-goosiness of JavaScript in the same way that I like the loosey-goosiness of Python. But if I had to say right now my favorite, I default to Python.
Okay, so it's not as strict of a coding language. It's not like you can mess around a little bit with the syntax and it doesn't break everything. Is that what I'm getting?
Well, you can't really mess around too much with syntax. Syntax is pretty much how the language is going to get parsed. But you can be a little bit loosey-goosey with what is stored inside of variables. A language like C++ requires, or Java would require that when you instantiate if you have a variable, you have to give it a certain type. So it has to, be an int, or it has to be a string, or it has to be a double. Whereas in Python, everything is just an object, and if it was an int, you can overwrite it and make it a string. If it was a string, you can overwrite it and make it your own, user-defined object. So that comes with its, advantages and disadvantages. The advantage is that I can kind of just be loosey-goosey about not having to worry about, hey, what was this object? What is it now? And because I can do that, I can also create problems for myself when I code, if I code somewhat sloppily, because then I overuse variables and what have you. But I end up liking Python just because I like the fact that, hey, it's just a script, and some of the things that I wanted to do just felt so much more natural than what I was doing when I was programming in C++.
All right, very cool. Good promotion though there for Python, and that's one that I would say if I really wanted to drive in and learn. I know Google Scripts runs very similar as JavaScript, but Python always seemed to be one I was interested in. I don't know if it's because it seemed easier to get started, like it was more of a beginner type language, or if it was more, I'm trying to become a fan of open source stuff, and I know a lot of that is Python interconnected, I think.
Sure. There's Python certainly is used. JavaScript is used. It just depends, I think, on what way you want to use the language. Right. Some languages are actually more geared towards a certain type of development than other languages.
So while we're on that topic, and I think that this actually segued really nicely into another question I had. What would be the advantage then of using Python over, let's say, JavaScript, over, let's say, C++, and we can come back to this other part later, but the other part would be this. Do you see an issue with starting with block-based coding? Do you see an issue with that? So kind of a two-parter there.
So like block-based coding meaning something like Scratch? Is that what you mean?
Yes.
Yeah, no, that's I think something like Scratch is aimed very much towards beginners, and I think for young beginners. Is that true, or is it just a language for beginners, anyone who's completely novice to programming?
I think, and Tara, you can offer your opinion on this too, so we can get your face on screen here, of course. But I think that it is meant to be geared towards younger people. I do. Like, yes, it's a beginner, but I think it's a beginner younger just because of some of the like the training materials, the built-in sprites, and just kind of the setup kind of speaks like more of a young type thing to me.
For Scratch or for block-based in particular?
Let's just say it's for Scratch.
Okay. I've talked to some college professors who've actually said that they have their students, like computer science students who are coming in who don't have any coding experience, start with block-based coding and the argument is that with block-based coding you get that problem solving and you get that part of your brain thinking critically about how to approach a problem so that when you get to script-based coding it makes more sense instead of just jumping into all of these different variables. What are your thoughts?
Interesting.
No, I was just going to say that I think that there's lots of ways to teach programming, and certainly something like Scratch obviously has made a mark. It's very visually appealing. It has a lot of it is designed to promote how to program. So I wouldn't say ever that you shouldn't use it or you shouldn't do it at all. I know that for me, at this stage, I probably wouldn't use it for myself. And when I do teach others to program, I've not actually experimented with Scratch enough to say that this is something that I would or wouldn't use heavily. But with that said, what I do want to say is that the idea here is that, hey, look, I don't even understand how code is supposed to work. I don't understand any of even the premises. So something like Scratch, I mean, I've looked at it. It actually looks very nice. I like the fact that you don't have to get bogged down in all the syntax. You don't have to get bogged down in, oh, you have to declare these modules, and you have to import this, and you have to use a colon here and a semicolon there, and that becomes a little maddening. Because when I have taught, say, a C++ course, which, it's always a disaster when I teach a C++ course to anybody who's never had any exposure to programming, because what they fumble over more than anything else is getting their blasted code to compile. They simply cannot get it to compile, and you can't even ever get to talking about logic. You can't ever get to talking about, hey, let's think about writing a code that loops itself, say, 50 times or 100 times. I mean, it's just a for loop that you have to use, but the syntax for a for loop is a little confusing if you've never seen code before. So something like Scratch, yeah, sure. I would say it works for beginners. One of the things that I like to do when I teach a programming course is my first lecture, I don't even like to open any type of programming environment. What I want to talk about is programming without the computer. And I wrote something about this a little bit ago. But the basic idea is that we have a lot of things that we do in our day-to-day that we can think of in a programmatic way. Like when you look at, say, a recipe for making a soup of some sort, at some point the recipe says, let water boil, and then once the water is boiled, add whatever you're supposed to add to it. that you can make an argument is a wild statement. While water not boiled, um, wait is basically what you have to do. So I like to whenever I taught a programming course, that's what I like to do, at least for the first lecture, is, hey, if you've never programmed before, let's start talking about some of these elements that we're going to see. Looping, while statements. Hey, what is this object that we're working with? I also just like to ask my students, how would you tell a computer program, or how would you write a computer program to make a grilled cheese sandwich, right? If you had a robot, if you had an android who you could say, you could program to make a grilled cheese sandwich, what are all the instructions that you have to give? And then you can see that, when you want to write a program, you actually have to be very specific about all the little details. Because I want to make a grilled cheese sandwich, well, I can say that to anybody, and we ignore all the little details, which is, oh, I need to get a pan. I need to put the pan on the burner, and I need to turn the burner on. But I can't just say put the pan on the burner, because there are 4 burners on my stove. So which burner? Front right, front left, so on and so forth. Okay, well, I've taken my pan, I've put it on the burner. Then what do I do? It's not then make grilled cheese. Well, no, it's add butter or oil, and you have to say how much, and all those little details. So I like to get my students to just talk that through, so that they understand that, oh, you are really spelling out all the little instructions that you want to have gotten done, just to make something as simple as a grilled cheese sandwich.
That is brilliant. That's just such a good idea. I feel like I should get some of the FACE teachers that I work with doing that, just because they can integrate that so easily and just make it as an aside. So I just love the thinking there, is that you have to really break it down to the fine points, and you can't leave anything out. Tara and I were at EdCamp Chicago a couple weeks ago, and in our session, and I think it eventually came up, and I think Tara's the one who said it, is if you miss something, so you're talking about how it's kind of maddening when students can't get their code to compile in C++, and because they missed the semicolon or something. On the flip side, especially if you're going with our angle where we would like to see more programming in curriculum, you look at an English class, and it's really important to have your punctuation and your capitals and your sentence structure in a certain way. So I believe Tara made the case, and you can correct me if I'm wrong, that it's like if you miss something, if you miss one of those pieces and your code doesn't run, it's like in English, if you forget a period, it's like that sentence doesn't exist.
Exactly.
Yeah.
Yeah, it's like, I mean, for primary especially, like you've got your kindergarten, first and second grade taking spelling tests, and the teacher will count the entire thing wrong if the punctuation isn't correct, if the period's not there, if the capitalization is not there. And so that's why, like, it just makes sense to start teaching programming at an early age, because they're already learning those types of detail-oriented concepts.
Yeah, what's interesting is that the difference between say something like English, or just your our spoken language study versus say a programming language, they obviously share the word language. But one of the things I said to the last time I taught a C++ class, one of the things I said to my students was that, hey, listen, you are trying to talk to the computer, and it is actually one of the best negotiators out there, because it's not yielding to anything that you are trying to imply. It doesn't understand context. It doesn't understand, in English, when I write a sentence, or we see this all, right, with the grammar guys who say, hey, the grammar and the spelling guys who say, listen, it's your, Y-O-U apostrophe R-E, just get it right. But we can write a sentence. We can write a sentence and use the incorrect spelling. And for the most part, we people can understand the context. We can kind of just forgive it, right? You can say, oh, okay, that was a typo, that's a mistake. I know some of us get a little bit more angry about it than others may. But the truth is, uh, we don't actually not understand what was the intent. Whereas in a computer program, it will say, well, you type this in, and so that's what I'm doing. Um, and it is just unforgiving. It is. I have said that it's the perfect negotiator because it doesn't budge. It says this is what I want. And if you didn't give it to me, then I don't care. So yeah, harping on that syntax is vital. But it actually makes programming very frustrating for the new person because there's two things that they're trying to reconcile at the same time, right? The first thing they're trying to reconcile or not the first, but one thing they're trying to reconcile is the syntax. But the other thing they're trying to reconcile is the fact that I'm trying to program basically something that is, and forgive the language here, but it's just stupid, right? The computer in some sense is just, it will only do what you tell it to do, not what you intended it to do. So when students are trying to fight those two things, at some point the educator has to pick, well, which one do we want them to fight first? And not to bring this back to math, but this is, to me, is one of the problems with learning mathematics. You have the whole syntax of written mathematics, but then you also have, the logic that's underlying all of this. And students are trying to simultaneously learn both, and it becomes a disaster because if you write, and I look at math syntax a lot more strictly than I would say written language syntax. If you look at, x plus 3 equals 7, and you say mixed up the 7 and the 3, and you wrote x plus 7 equals 3, well, now you have, two different equations. They're two different sentences. They mean something different. Whereas in English, if you, flipped around a word here and there, of course there are going to be contexts where, yes, there's lots of jokes that are made. Puns are a good example of this, where we can play with the words and get completely different meanings. But with something like mathematics, students have the same problem. They're still trying to get a handle on the logic. But at the same time, we say, nope, you also need to write it correctly. And so when both of those things can't get working together simultaneously, it's a headache. And the same thing goes with programming. The students can't simultaneously figure out the syntax and the logic. And that's why something like, something a little bit more abstract like Scratch, where you just need to, drag and drop these code blocks into the right spot to make your logic work. Once you understand, programming, reasoning, and logic, now let's talk about syntax. And I think that's a reasonable paradigm. But I think you could do it just the other way, just the same, except you would forego application for a long while, and you would say, let's figure out how to actually write a for loop. Let's figure out how to actually write, declare a variable. Let's figure out how to write a while statement. Let's figure out what an if-then clause is, or if-else clause. But you wouldn't do any application, which makes it a different type of situation.
Yeah, I totally agree, and that's always one of the criticisms I've read of block-based coding is that, well, it's not real programming, and once the kids reach real programming, they might not want to do it because it's too hard. But to speak to your point, if you start with that hard syntax right away, yeah, I think you're going to have students who, when they make it through that, are going to be better off maybe a little bit. But when you're talking about an industry that's trying to rekindle a passion that's kind of like dormant for a while, you need to get people making stuff with this right away before you lose them on the syntax. And that's the way I'll justify Scratch to the ends of the earth, because now I have kids who will go in and they'll make this amazing movie, and then we can go to something else, and they've already had so much success and some failure too, that they want to see what else they can do, and they want to see what else is out there, and it expands their mind to something they didn't realize existed. And I only see it as being beneficial because, like you talked about back at the beginning, all those little experiences added up, and that's just what we need to do, is get those little experiences in place, whether it be Scratch or JavaScript or something else. So
yeah, that's right. and I think that, some students are going to respond better to, hey, here's the syntax. Let's just write in the syntax. Certainly, because I knew, my classmates when in high school and in grade school, some of them were just good programmers. They were programmers. Actually, they worked fluently with C++ back in the day, whereas I was still struggling with just managing the syntax itself. And I think that those students probably would have been turned off by something like Scratch, because it was. I think that they would have been able to see through the fact that this is just one layer of simplicity that they didn't need, and they could actually have just gone straight into programming directly.
And you speak to kind of the whole mission of education, one of the big trends, personalizing the learning, that not every kid needs the same thing. So
that's exactly right.
Yeah, great point. Having lots of tools in the toolbox is always better than having just a hammer.
Yep, absolutely.
All right, so moving along here, some of the other questions that we had for you. I know you've talked a lot about math and coding, so I'm going to see if I can try and segue and grab a few of these together a little bit. I would like to see, and I think Tara would be interested too, and anybody who might watch this in the future, to kind of see some code get put together. We talk a lot about coding this, coding that, and I think a lot of us are familiar with like how Scratch could be put together or block-based. But as far as like actual written code, I think it'd be cool if you'd be so willing to give us just a little demo.
Sure. Let's see, how does this work now? Screen share of some sort, right?
Yes, the green one with the white arrow.
All right, let me get some things set up here. Screen share, green thing with the white arrow.
And while we're getting this set up, if the audience has any questions, feel free to use the question and answer app, and we'll get to your questions towards the end of the show.
All right, so it says select the window to show in the video call. Oh yeah, we'll show this guy. So I assume that you can see I have a Python shell open. This is just Python as a language, and here this is just the shell. That's all it is.
Shouldn't they have called it like Python skin? Wouldn't that have made more sense?
Maybe. Yeah, maybe. But the word shell has I think a historic meaning that predates Python. But so in any case, so we want to put together some code that does something. Well, maybe we can solve I don't know, an algebra problem of some sort if we wanted to. The idea here is that, and Josh, I think you said that, hey, Python is a language that you would like to have learned or dived into at some point.
Mm-hmm.
So what do we want to write here? I guess is a question. Here's a simple thing, right? One of the things that students have to do is they have to, I don't know, at some point in grade school, they need to learn some arithmetic. So we have the Python as a language itself, in the shell environment, has the ability to do simple arithmetic. So there's some calculator ability there. But maybe what we want them to do in terms of programming is actually to write that plus operation, right? So if I can make a function that says add numbers, and this is an oversimplification because it already exists in Python implicitly, but I can say, okay, add numbers, and well, what would I like to add? I would like to add two numbers, x and y. And what would I give when somebody gives me two numbers, x and y? Well, I would return their sum, which is x plus y. So then what I can do is I've now made a function called add numbers, and I can function, and so I'm going to add 3 and 4, and I get 7.
Wow.
Is that visible? So I can also do 4 and 3. And now I get 7. But why this is interesting and important is we can see that Python, there's that plus operation that we teach students. It's plus, and you can use plus for adding numbers, and that's how you use plus. But But we've seen the use of plus in say, advertisements and Pictionary and games like this where, hey, you can use that plus to mean addition in a more abstract sense. So in Python, you can say, you can actually add two, right? Strings are basically letters that are put inside quotes, for lack of better explanation at this point. So I can say something like add numbers, but I can give it hi in there, and it'll concatenate the two strings together. And I got hit here or hi there, depending on how I want to read it. But so the idea here is that, okay, look, I wrote something that was supposed to add two things together, and now we can start talking about. We can actually start talking a little bit about objects, like what was this x here? What was this y? And who said that it had to be numbers? I decided to add, this word with that word. And then you can start to experiment, right? With just a little bit of code like this, you can say, well, can I add a string with a number? Will Python let me do that? And then you hit enter, and you get the unfortunate red text that says type error. Cannot convert int object to string implicitly. And so this is where a conversation begins, where we can start talking about, well, let's talk about objects. And this is really where mathematics can be brought in, because we do want to actually talk about the objects that we deal with. I have students who too often just say, oh, you gave me these two numbers, I guess I'll just add them. If I was recently told of this, that some first graders or second graders, they will get a problem like this two-digit addition, 34 plus 12. And when written like this, 34 plus 12 across, they will add and get 46. But if the numbers were stacked on top of each other, so the 34 on top and then the 12 on the bottom, and they went to add it, what the students would then produce is actually the number 10. Can you see how that they would produce 10? If they had to do 34 plus 12?
Yes. Because they added 3 plus 4 plus 1 plus 2.
That's all they did, right?
Which is
and
logical.
Then they get 10. Yeah, it's completely logical. It's completely logical. But now the question, now really you can start to have this conversation about, well, let's talk about context. Let's talk about the objects that we're working in. Let's actually talk about this operator, plus. What is it? What is it supposed to do? They were clearly adding, and they were clearly adding digit by digit, but this wasn't the context that was specified. So in any case, that's sort of the high-level conversation. But okay, we want to put actually some code together, and so now I need a project of some sort. What should I put together? Should I put together something that counts by 2? Should I find,
prime numbers? Can you do prime numbers?
Prime numbers on the fly. Oh God, yeah, that's going to. Yeah,
I was trying to think of
now.
what's simple enough for you to accomplish in like 2 minutes, 3 minutes.
Well, yeah, I'd have to. Let's see. I could probably do prime numbers, but now this is a live thing, and now I'll get criticized. Okay, let's see. Prime numbers. Okay, so define, find. How about this? We'll say is prime. Now that's probably a lot easier to do. So this is just going to check to see if a given number is a prime number or not. And I will do it in the stupidest possible way I can think of doing it. What we'll do is we will simply say, I'll have a counter, or I'll just have a current number, and we'll start. If a number is prime, then if I try to divide it by any number that's less than its square root, it shouldn't divide it. But for the sake of simplicity here, I will run the stupid algorithm, which is saying the following. So y is then x. We can optimize this, but we can optimize it later. So if x modulus current number is equal to 0, that means it divides, return and then current number plus equals 1. So all that last line there does is just it increments current number by 1. And so if we get through this, let's see. Hopefully I didn't botch the logic here. Current number. Yeah. If it gets through this, then that means that if it gets through a while loop, then clearly there was no number that x that was a factor of x that was less than x, and so now I should end up recognizing that I have a prime number here. So of course this isn't going to work for probably some base case that I've forgotten, but we'll see if this works, right? And we'll actually just get to see if the model of coding is going to make any sense. Meaning, hey, you made a mistake, now go and fix it, right? We'll learn how to debug it because I'm sure I probably screwed something up. So it's for a prime number. Hey, it says false. Good, because it probably divides something. Is 13 a prime number? Hey, it says true.
Nice.
How about this guy? 10,101. Apparently that's not prime because 1 plus 0 plus 1 plus 0 plus 1 adds to 3, so 10,001 modulus 3 should be 0 because it has no remainder, right? So if I do this division, I get, what is that, 367. So if I do 367 times 3, I get exactly the number I was looking for, 10,000. Or, oh, I misread the number. That's just the problem. 3,367. Yeah, there you go.
Yeah.
Yeah. So clearly I'm not doing any arithmetic in my brain because I'm just letting the computer program just basically take over my brain for the time being. But yeah, so here's a simple is prime, right? So I don't know. What's your favorite number, Josh?
22.
22. Well, clearly that's so yeah, we can play this however long we want. Hey, apparently that's prime. So
867.
867. So that won't be prime because it adds to that. It's a three is a divisor of this thing.
Wow, maybe that would be a discussion for a different time, but there must be a proof or something for why when you add all the digits together and that number can be divided by 3, then there must be a proof for that, right?
Yes, there is, and I've written one, so I'll send you the link for that at some point.
Oh, good. I'm looking forward to reading more of that, and hopefully in time, maybe in about 10 years, I'll understand what you write on your blog over at mathmisery.com.
I think you'll understand it. But okay, so in any case, this is a simple is prime function. But now here's what's interesting, right? What would happen if I put in like 0.5? Well, it's going to tell me that 0.5 is a prime, but we don't think of fractional numbers. Why would you even ask this question? So here you can actually have a small conversation about, well, look, what did the program, if you take a look at this is prime function or is prime method, what was it doing, right? It doesn't understand that it's supposed to get integers. It doesn't understand that it's supposed to get whole numbers or even just positive integers, right? You gave it 2.4343, and it executed this command. That's all it did. So this you can start to have a conversation about types. The type that it was expecting was an integer, but we gave it a float, right? So in Python, you have these things called types, so you can see what the type of 3 is. And so what we can do is we can go back a few if the is equal to int, then execute this command here. So basically, this is letting this program work only when I get integers that are bigger than 0, and if otherwise, right? That's this other part here. But I guess from an educational standpoint, I should really take it as statement. Otherwise, return empty, like return none. So now if I try to ask it for run, I got nothing back because it didn't try to do
Wow.
it. I tried to say it's negative, and it'll still give me nothing back because it wasn't. I tried to say hi there, it gives me nothing.
Wow. I don't know about you, Tara, but I'm absolutely riveted right now. Like that was amazing to see him make that in literally 3 minutes.
Yeah, the math like geeky side of me is like really like I want to know everything.
Yeah, and I mean
Wow.
this is this is fairly basic. If I felt up to the challenge, I would probably write a prime number generator, but I would rather not have all the world's peering eyes saying, "Hey, you fool! Why are you writing your prime number generator this way?" Um, but but yeah, I mean this is the basic idea, right? You start, and I think one of the things that happens. Hey, actually, can I close the screen share so I can see your
Oh,
own
yeah, go
faces?
for it.
Yes.
Well, okay.
Yeah, yeah, no, go ahead,
No,
ask
go
away,
ahead, go
ask
ahead.
away.
No, no, you're fine.
Okay. Stop screen. So one of the things that I think kids and people, anyone who wants to do programming, is that we have this sort of mystical idea of what it's supposed to be. We built it up into like this thing that will let me do these crazy things, right? I could write this wonderful website, or I could write this great web app. But really, where it has to start, it has to start small. It has to start with small, simple programs that, in effect, actually just do nothing. They're kind of pointless. They're like, oh, okay, well, why did I need to write that program? Um, you needed to write that program just to get your programming juices flowing. You needed to write that program so that you could see what correctly executed code looks like. You needed to write that program so that you could get a little bit more of a feel for the syntax. And also, you needed to write that program because it is it is from the smaller things that we build the larger things, right? We don't just say, when I even that simple is prime function, we can look at it and say, okay, well that clearly works. Then the next modification I made was, well, it's clearly working a little too well because it's telling me, it's actually giving me an answer for 43.3. So I wanted to make that modification that says, no, I control the inputs and just let it be integers, and they have to be bigger than 0. That's actually all I wanted about it. But then you can say, then you can start asking other questions, which is, well, can this program run a little faster? Why do I need to check all the way up to one number less than the number that I want to check up to? You don't actually need to do that. You just need to check up to the square root. And then you can say, well, do I really need to actually increment by ones? I can probably just increment just by the odd numbers. I don't, if you wanted to make make it just a little bit faster. So there's all those little incremental improvements that people make, and I think what people see is the final product, right? Something that's polished by people who have been programming for a long time, and they want to jump right to that final finished product when you really can't. You really ought to start at something that's simple. It looks kind of hackish. Your code looks hackish, but that's where you start. It's the same way that an artist works with a drawing or sculpting anything. The first sketches are always rough, and then you polish it up, and then you show the world the final product. Which is polished and clean, and it looks amazing. You don't show your scrapbook.
Yeah. So are you still, as an aside note here, are you still working on learning how to draw? Is that still a thing you're working on?
Yeah. I have. I'm trying to do a weekly comic.
Yes, yes.
And that's really the attempt at forcing my hand at and literally my hand, forcing my hand to draw properly, because I can always just keep sketching on my own, and it'll never go anywhere. But if I force myself to just, what, just show the world what you have, and people probably won't like it, but if you want to continue to do this, you just have to keep drawing and making those incremental improvements. I can't just immediately go to fully developed, you know, comic strip, and I can't go to a fully developed, you know, character design. It's going to happen in stages. To give you an example, I actually have it on the side because I had to give my students an exam today. So what did I do? I was doodling. I don't know if you can see the doodles. Are they visible at all?
Yes.
Are they visible? Yeah. Yeah. So anyway, you know, those are it's just, you know, an experiment because I want to try to figure out how to make these characters, right? I've read comics as a kid. I watched cartoons as a kid, um, and I like, you know, I like art, but it was something that I never did as a kid. And as I grew older, I said, well, why didn't I ever do this? And so it was, well, this is something that I now need to do.
Yeah, I can certainly sympathize in my own life, and I think it's a good parallel as we talk about, you know, our students and our colleagues and trying to expand our horizons past our comfort zones. So Manan, I know you know this, and Tara, I know you do too, that I've been working on writing a story for NaNoWriMo this
Yep.
month.
And what does NaNoWriMo stand for?
National Novel Writing Month. And, you know, like I tell people, I really don't know when I started. Like, I decided to start like days before. But, you know, it all just came back to this idea that, you know, like this year especially, I've been doing a lot of things that I've never done before, that are way outside of my comfort zone. And, you know, it's really scary at first because, you know, you're in your comfort zone, you feel good, you're safe, everything's working the way you want it to, your world just kind of goes on. But once you finally like push past some of those like fears and insecurities, like your insecurity of putting your drawings out there until they're good. Like, even though I know you were sharing your drafts along the way because I remember seeing them, but I think once you push past that and see, oh wow, this is really cool. Why didn't I do this before? Like it becomes a little bit of a rush, and you want to keep like pushing yourself more. You know, so it's been simple things, but like writing the story, you know, ties that back into what you're talking about with code, like little by little. You don't write a 50,000 word story in 1,000 words. Like you have to build the story little by little. And when you have a month to write it, you're literally coming up with things on the fly and having to keep the ideas flowing by just keeping to write and just forcing yourself to keep going back to it and improving it and making it better and tinkering with different styles and, you know, trying, okay, this is going to be a dialogue chapter, it's going to be lots of talking, and the next chapter is going to be lots of action, and how do we describe like all these different things. And it's been so much fun, but a lot of work.
Yeah, absolutely, absolutely, and you know, I think it's, again, you are doing it one step at a time. There's that adage of a journey of, what is it, 6 steps begins with 1 step or something like this. Or I don't know what it was. Like, you can't move a mountain without taking away stones. I don't know. It was something like this. But yeah, this is exactly the idea, right? You just can't go to the final product. You have to start small. And that, you know, with programming, with anything, is always frustrating because we always see the final product from professionals who've been doing it for 20 years, for 15 years. You know, they've been doing this for a long time. And I think that, especially for adult learners, I think that sometimes there's just this forgotten respect for the fact that people have been doing this for a long time. And with the younger learners, it's, you know, I don't think they understand what 15 years means because they've been only alive for 7 or 9.
Yeah.
So you know, but I think with younger learners, their maybe their scope, their field of vision isn't as wide as say older learners. So in some sense, you know, the younger folks, they're a little bit more pliable. But with older folks that you want to teach programming to, you have to first, I think, get them to be humble about the fact that, look, the people who've been doing this, they've been doing it for 15 years. They've been doing it for a long time, and they've put in, you know, not just 10,000 hours. They've put in 50,000 hours. They put in, you know, a lot of sweat equity.
Yeah, absolutely.
Well, and I
Go ahead,
think to
Jess.
kind of, oh, sorry.
Go ahead.
We still have time? Okay, cool. I think to kind of piggyback off of what you were saying, as far as adults are concerned, we kind of do have the same problem with students because academically, students who are used to getting straight A's and students who are used to being like at the top of their class, you introduce this new thing to them, and if they don't get it right away, then it's hard for them to persist. And it's hard for them to overcome that, to basically be humble enough to keep trying. Whereas students who academically are used to not doing maybe as well as the average are used to persevering, are used to iterating. So it's more natural for them. Do you notice that at all?
Do I notice that?
I mean, have you worked with students who like match one of those?
Well, so here's at least in my math courses, I see the following spectrum. Right? I see the students who have gotten, and I hear it every semester, but I got A's in all my math classes, and in this one I'm not. Certainly, there's that breed of student who can't actually understand that they don't understand something. And that means that they were actually never really challenged at the earlier in their life. They were whatever it was came easily, and for better or for worse, they weren't pushed along the way to say, okay, well, we're clearly blown right past this limit, um, rather than say we're not going to. I think what happens in a lot of students is, okay, you've blown right past this limit, but we can't go any further. That's really what happens, so that when they get to college and they actually are not blowing right past the limit. They don't know what to do. So there's certainly that class of students. There's the other class of students who they've continued to go past the limits, but they've done it because it hasn't quote unquote come naturally. That is the student that excels in practically any environment. The student who hasn't done well academically, I think, and I don't want to get too far off here into probably an unprovoked rant, but no, but I think the student who, at least what I've seen, the student who hasn't done well academically, I think has been told all his or her life that they're not a good student. So they have now come to college and they find themselves struggling again, but they now have the option of giving up, and I think they just give up. I see a lot of students on a semester by semester basis, if they just stuck it out, and not just to accumulate the points, but if they just stuck it out and said, let me try again, 3, 4, 5 times, they could actually succeed. Whereas they fail the first time and they have become accustomed to this pattern of failure throughout their life, and being told in some sense that you really can't do this, they just give up. So I find that the students who succeed the most are the ones who have gotten some measure of success, but that measure of success came with effort. Whereas
Right.
the ones who hadn't made an effort on either side of the spectrum, they tend to just collapse, either in college or later in life.
And that is an interesting perspective, just because we are in the K-12 system, where we don't really see the higher ed side of things, and you kind of get kind of the back end of what is produced by our educational system at this point. So I like that perspective, and it's always good to keep that in mind as we make decisions kind of down here at our little corner of the pie. So
Well,
corner of the
and
pie. There is no corner in a
well,
pie.
I mean, and to caution, just to caution, I'm one voice, and I certainly do not speak for all the folks who teach in higher ed, but those are at least my experiences. Of if I had to break down students, classify students in terms of how they succeed and how they fail, and I think it just comes down to trying to instill in them somewhere, somehow, that if it's too easy, then make it hard, some way, somehow. And if it is
Definitely.
if it is already hard, then seek help, because I have students who it's hard, so they give up. They don't ask questions. I get no emails. I mean, I think every professor will have the story where they say, well, they throw their hands up in the air and say, this isn't for me, and that's the end.
Well, you've certainly provided like a ton of great one-liners, but aside from that, just a wealth of information. And I have to say, thank you for doing that live demo of Python. Like, that was incredible just to see you were talking about your thought process as you went through it and as you put that together. And not only did you do that and had some success and some failure, but you were able to do like debug it on the spot and make it work. Like that was incredible. So just thank you. I really appreciate you taking the time with us tonight, and when we kind of share this out and other people start to watch this, I think they're going to really like to meet you. But I think you've got so many great things that you said, and you touch on a lot of good areas with math and programming and kind of that need to persevere. So just thank you. Really appreciate it. Anything you want to plug before we?
I mean, I'll simply apologize to all the Python programmers out there, because I'm sure if they saw this, like, oh my God, this is how he's promoting the language, this is. But no, it's a simple, silly demo. If you go to python.org, you get a lot of good resources there. They have a wonderful tutorial. That's actually where I picked up the language. As for personal plugs, I mean, there's my blog, mathmisery.com. I hope I don't have to create a website called codecrankiness.com or something. But yeah, that's who I am, and you can find me there for sure. And thank you for giving me the opportunity here to talk with you guys. It was fun.
Anytime, Manan, anytime. So thank you to those who took the time or will watch this in the future. And we hope that you'll join us again as we have another exciting round of guests coming up. We've got plenty of fun guests in the work, educators who are doing just awesome things when it comes to programming in education. So thanks for watching. Thanks for joining our community here at Coding Connect as we look to push past the second hour of code and beyond. Have yourselves a wonderful day.